Okay, so I'm going to keep going. I think I'm going to do 38, 39, 40, and 41. And this is the regression chapter. And it's really not that bad. I'm going to show you some cheats to help you with the final and make it easier. Okay, so question. Consider obtaining a random sample of 100 people and measuring the height in inches of a person and how frequently he or she attends religious services. Determine whether you believe that the two variables are correlated. If they're correlated, determine the correlation is positive and negative. All right. So this is a weird one. Height. Height has to do with a lot of different things. It has to do with your genetics, growth spurts, sometimes how much you eat, stuff like that. It really has no bearing on if you go to religious service. So I wouldn't even say these are positive or negative. I would go down here and say they are not correlated because they're not. So height and religious affiliation have really nothing to do with each other. Okay, you can't. Your height doesn't tend to increase if you go to religious services, and that's what they're looking is so that you understand. Just because you try to have a correlation between two variables doesn't mean that it exists. Okay, the most famous example that I usually teach is murder rates and ice cream sales. That there's a correlation that as ice cream sales increase, murder rates increase. Well, there is, but that's not the cause. The cause is because it's summertime, and as the temperatures get hotter, ice cream sales increase as well as murder rates increase. But that doesn't mean, again, that ice cream sales and murder rates are correlated. There's something going on that make them both increase at the same time, and it's temperature. Okay, so let's look at this. A following table lists the height in inches and weight in pounds of a sample of football quarterbacks. Compute the correlation coefficient. And I'm going to show you here. I know the answer is shown, but I want to show you how to get it easier. All right, I have a bunch of data sets right here. I have 3 different data sets. So what I did is I typed them all into a Excel document. In the University System of Georgia, you should all get Excel for free. Go to your home institute, and if you don't know, email like IT, and they can show you how to get Excel for free. So if you look here, I've done 39's X, 39Y, and I've done it for all the problems. I'm going from top to bottom. So 77 is if the X is 77, the Y is 232. And look, it's the same here. 77, 232, 76, 225. And all I did is I just, instead of putting them the long ways that they did it, I did this one vertical. They did it horizontal. So SALT will read it. I did it vertical. Okay, again, I got 39, 40, and 41. And I did my X's and my Y's to make sure. And when I save it as a comma delimited file. That's the only thing SALT will read is those. And I'm going to hit OK. And I know where it is. So what I'm going to do now is I'm going to go to SALT. I think I've got it up in a different window. Hold on, let me find it. Yeah, I have it here. So I'm in SALT. I'm going to do upload CSV. I'm going to go look for it. I think I put it on this page. Yep, problems 39, 40, and 41. I always put it on my desktop because it's easier to do. So I click on it, and I'm going to say, yep, I'm going to select all my variables just so they all come in and I know where they are. So I'm going to do select 6. Look, it loaded my variables into SALT. Okay, now remember the problem said correlation coefficient. Okay, so what I'm going to do, not that, I'm going to go back here and I'm going to go to regression. Okay, select a variable. I'm going to do 39x, and my response is 39y. All right, so here is the graph. It's showing me, here's the regression line, and this, I'm going to do this. Oops, I'm going to unclick it. So this orange line is my regression line. It created the regression line. If I do this, these are called confidence bands. They're very similar to confidence intervals that we learned before. All right, but I want to keep going down. So remember, it asked me for the correlation coefficient. Well, the cool thing right here is my correlation coefficient. It's 0.9245. So there it is. And it wanted it as 3 decimal places. So I take this, let me do this. Sorry, I don't like that it did that. Let's put it here. I'll put it here. And then if I round it, I get 0.925. And that's the same as the answer right here. So all I did is I put it in SALT, the data, and then I ran it and it gave me my correlation coefficient. Okay, so that was for 39. All right. And if it had asked, say it had asked for my line, here is my regression line right there. I'm just going to put it here just so you can see it. And here is my regression line. I'm going to put it right here. Okay. So I have that there. And remember the 39y, it just is the y and this is the x. Okay. I know it's a little bit confusing, but if you could do it like this, y equals x times, and this is multiplication, that. Okay, so that's really my line of best fit or my regression line. All right, so here it goes. List following tables list the ages of a sample of couples on vacation cruise. All right, so here they are. So x and y, and again, I already put that in my data set. The least squared regression line is in the form y equals bo plus b1x. All right, let's break this down. Okay, so y equals bo right here is your, let's do this, we're going to copy it. bo is your y-intercept, and b1 right here, I'm just going to put it here, equals your slope. Okay. All right, and it wants me to find the slope. Okay, compute the slope because it tells me right here, compute the slope. Okay, it's really easy. Oops, it's really easy to do, and I'm going to do it in this color just so I know where it is. All right, I know I'm using a lot of different colors, but it makes it easier for me. All right, so I'm going to go back here, and now remember I'm doing problem 40. So I go back to SALT. I'm going to do 40x and then 40y. Okay, here's my line. Here's my regression line. So then I'm going to go down here and I'm going to take this out, okay? Because it gives me everything I need. So I'm going to put this here and then I'm going to interpret it, okay? So I'm going to put it here, right? But remember, this just really is y and this is x, okay? And this is multiplication. All right, so I don't have it in the exact same way, but I'm going to highlight it. This is the y-intercept, and this is the slope. Okay, so my slope is 0.9737. And if you look down here at the answer, there it is. It's that way. And SALT did it for me. I didn't have to do anything else. All right, so let's go again. So now for number 41, it's looking at the number of absences and grades earned on the first exam. Okay, so again, it's looking at the least squared regression line, but now it wants to find the intercept. Okay, remember I did this as yellow, and I'm going to do this again as yellow, and I'm looking for this right here. Okay, so again, I'm going to go to SALT. And I'm just going to change my data set. So now I'm going to do 41x. I'm going to do 41y. Okay, got it? And now I see here, exam grades. So here's exam grades, and these are absences. And I'm looking to see what it did. All right, so now what I want to do is I want to go down here and grab this. Again, least squared regression line. All right, I'm going to put it here. Again, so this is y. And this is x. And this is multiplication. Okay. All right, but it wants me to do the intercept. So if I look right here in yellow, here's my intercept, and that's the same answer. So that's what I got. So there's my answer. And again, I didn't have to do anything by hand. All I did was use SALT. But the big thing that I had to do, though, is I had to put my data in Excel file, change it to a CSV file, and then I uploaded it. Okay, that's all I did. Because when you're usually using salt in WebAssign, it already has your data set in there. I hope that helps.